Welcome to the final day of the Meridian technical track. So before we get started, just a few quick questions and suggestions. One, have you checked out the hackathon tab and voted for your favorite hackathon project? Before the close of the day, we're going to tabulate all the votes and announce our winners. So make sure to get in there and let your voice be heard. Democracy. Two, have you played around with the Meridian photo booth? It's actually pretty fun. Snap your most creative shot, decorate it with stellar stickers, share it on Twitter with the hashtag Meridian2020. We're going to pick the 10 best photos and award the takers of said photos with some swag. Three, don't forget tomorrow is networking day. It's a great chance to hobnob, meet fellow attendees, and share your feedback with SDF. So sessions have limited seating. Make sure to head to the interactive sessions tab, see what's there, and sign up for any session that you're dying to attend. Now, on with the show. So over the past few days, we've learned all about the network and the protocol, about Stellar Core and Horizon, about issuing assets, anchors, and DEX liquidity. We've explored new strategies for key recovery and new ideas for creating Stellar smart contracts, and we've seen user-friendly apps and on-off ramps in action. We've packaged up all of 2020's big technical developments, and at the end of today, we're going to tie a bow around that package when Alex Cordero walks us through the SDF's engineering roadmap. Before we get to that, however, we have two very special sessions that focus on and cover topics chosen by the greater Stellar community. So in advance of Meridian, we asked for session suggestions and we circulated polls to allow everyone in the ecosystem to weigh in. There were two clear winners, a panel on Stellar for gaming and a panel dedicated to the growth and empowerment of the community itself. I personally very excited by both of those. But to kick off today, we're going to step back a bit and talk about a big challenge all public ledgers face, confidentiality. So how can businesses build on blockchain with selective disclosure? In this session, our all-star panel, Oleg Andreev, protocol engineer at SDF, Lindsay Lin, counsel at SDF, and David Mazières, SDF's co-founder and chief scientist, will explore approaches to protecting data and considerations for regulatory compliance. Oleg, take it away.
Thank you, Justin. How can you hear me? Okay, so welcome to this talk. I'm very glad to be here with Lindsay and David. So the plan for the talk is basically me giving like a short recap of what I was working on lately, which is a SLINGSHOT project and ZkVM transaction format, like a very quick recap. And then we'll talk about challenges that like anyone who would like to implement advanced cryptography to solve advanced problems will face from technical and from regulatory side. So to start off, let me just give you a short presentation. Where's the share screen? So, yeah. So this is a quick overview of what is a SLINGSHOT. So basically, our goal is to create a TLS for the ledger, right? So you want to send money from one point to another privately, but doing that in public. So you enjoy the trustworthiness and like liquidity of the single like publicly auditable ledger, but still your financial transaction wants to be private. So it's sort of like doing the TLS for web connections when you travel from one website to another on the public internet, but want to do so privately, so the whole world doesn't know exactly what data you're transmitting between your computer and the server. So what does this mean specifically? First of all, it means confidentiality for the sensitive data, which means that your balances and your account data should be encrypted. But since we're talking about the public ledger, we need some way to publicly verify, like everyone has to have ability to verify that your balances are accurate, that you didn't make stuff up along the way. So we need some zero knowledge proofs that your transactions are correct. And finally, since the public ledgers are having so many technical challenges in terms of scalability, performance, and different use cases, you want to have the whole system to be more or less customizable, so you can build interesting solutions on top of it without kind of redesigning all the time the underlying technology. Just like on the internet, you build on top of existing protocols instead of always like tweaking and redeploying the base protocols, right? Now, specifically, the Slingshot project is this entire blockchain system where there are many components. You have peer-to-peer networking, you have some cryptography, you have some signatures, zero-knowledge proofs, some high-level concepts like accounts and protocols for the wallets, some like nitty-gritty like transaction like format things, and the whole project is effectively providing you with this building blocks that allow you to build the system suited for your needs, because it's not quite clear kind of what decisions we should make like right away, but we know that there are some kind of important kind of building blocks that we would need so to kind of allow us to have some flexibility to figure out the perfect design. The whole project is engineered as this collection of libraries. Now, the central part of this project is ZkVM, which stands for Zero Knowledge Virtual Machine. So it's a funny word, but it's a simpler thing. It's just a transaction format that's seen somewhere between the underlying network and consensus mechanism and below any high-level protocols that you might have, like wallets, payment channels, some like layer 2 solutions, maybe some kind of decentralized finance things like order books and like programmatic futures or whatever. So what it means specifically is that the virtual machine is not really a virtual computer. It's more like a fancy parser for the transaction format. And to put this in perspective, think of the other blockchains as also sort of like transaction formats. So to compare with Bitcoin or Stellar, the transaction format is more like hierarchical, kind of static description of what transaction does, sort of like XML. And there are additional like rules that specify like what can and what cannot be in the format. Ethereum, on the other hand, is interesting. It's this global kind of computable state machine, and your transactions are like commands that you send into this machine. So the whole network is simulating this giant machine, and your transaction is just sending a command like perform this program or deploy that program. So it's like remote procedure call instruction. And the ZkVM is not quite like either of those. It's more like a PDF. So on one hand, it's kind of describing some structure, but at the same time, it's doing that in a programmatic manner. Like PDF is a little program that is the kind of stream of instructions that tells like what should be produced as a result. So PDF itself is, of course, the document like drawing format. So you can like draw text and graphics, but in ZkVM, what you're doing, you're telling where the financial value goes. So how do you unlock it, how you lock it, how to what conditions you check, and how do you check them. So effectively, what ZkVM does is three things. So it provides you with smart contracts through the concept of having all financial value being confined to isolated contracts. So this is how the state transitions are implemented. So if you need some, stateful logic, it's the contract that you use to do that, and all the value is locked in those contracts. And so you have to unlock them with signatures or with some extra proofs or extra conditions. Second thing is confidentiality. All the values and data are encrypted by default. So you can do some arithmetic and some kind of logic on these things without revealing them to the public. But of course, the actual operations that you do are revealed, but not the data that they are working with. And finally, ZkVM provides integrity check that whatever is happening within the transaction is abiding the conservation law, right? So you cannot make the value out of thin air, and you cannot unlock contracts in unauthorized manner. So that's the job of the ZkVM as a interpreter, as a parser for this transaction. So to have a quick glimpse of like how this looks like, you have these transactions where that specify the flow of assets, right? For you, the assets flow from inputs to outputs, and also you could issue new assets because ZkVM is for issued assets, just like Stellar. This is how the asset flow looks like. And most importantly, that those inputs and outputs are the acts of locking and unlocking the contracts. The contracts are those objects, if anyone is familiar with object capability pattern, those objects that guard the value. So you have to interact with them in a prescribed manner to unlock the value out of the contract. And this is a very powerful concept because it allows you to implement quite complex, like rich amount of applications with this. So you can lock one value, or you can lock multiple values. You can have extra conditions and parameters of these conditions right embedded within the contract. And once you satisfy the predicate, then you get those items out of the contract. So it could be as simple as just a transaction signature, or it could be execution of some subprogram that is either embedded or provided after the fact with the signature. So there's a lot of different ways to do that. So the kind of overall program execution looks like this. Your transaction is a little program and a proof. So what happens is that for each transaction, the VM is instantiated. It loads the program, it runs the program, checks the network rules during the execution, and then the VM is discarded. So it's very short-lived, like a parser, very lightweight thing. And it's designed to be not Turing complete, to avoid a lot of issues. So it's like a one-way execution, very fast, and the slowest part is just checking the cryptographic proofs. So there's no room for some like horrible denial of service attacks or some like intricate, contracts with like loops and ever-growing state to bring the system to a halt or to lose a lot of money in a careless manner. Now, once the program is executed, it has two effects. It has the transaction log, which is a list of inputs and outputs in the transaction, and the constraint system, which is the list of all the arithmetic constraints on whatever value and data parameters that were checked during the program execution. And the cool part is that this constraint system is verified with a single ZK proof at the end of the execution. So it's very efficient, uses the batched cryptography. So effectively, you have this like one run of the program and then one check of the single zero knowledge proof in the end. And if all of these conditions are satisfied, then the transaction log is applied in one atomic operation to the ledger state, which is super simple. It's just a list of unspent outputs or unspent contracts. So this model allows us to implement rather a scalable system because every contract, every transaction can be verified independently, and then it's just the matter of proper order of application of their effects to the ledger state, which is a very lightweight operation. Finally, kind of the important takeaway is that in ZkVM, the contracts are imperatively expressing their requirements. So they entirely avoid like huge categories of bugs like confused deputy problem and many like categories like some examples on Ethereum show. To kind of help kind of show in comparison with other system, I have a couple of examples. So first is with the Stellar. Of course, the important part is that ZkVM provides confidentiality, but also a few central concepts to Stellar are kind of pushed off chain. So they're not implemented at the core protocol, but kind of defer to the upper application layer, like accounts. As I said, verification is much more stateless, and your kind of composition is represented by VM instructions that look something like this. A little bit of arithmetic, a little like kind of a little bit of operations that work with values and contracts, and they are not quite low level, but also they certainly kind not as high level as Stellar's. So they sit somewhere in the middle and focused specifically on the financial applications, financial kind of checks, and focused natively on moving around assets. So comparing to Ethereum, Ethereum was much more closer to something like a CPU model where you do like raw just number crunching and some like kind of low level checks. And in Ethereum, you have to model your assets. So this brings us to this comparison with Ethereum, where you don't have first-class assets. You have to kind of implement mini banks on chain as smart contracts. And this creates a lot of overhead, a lot of complexity, which is completely taken away out of ZkVM because it's focused on assets from the get-go. And finally, if you compare ZkVM to privacy coins such as Zcash and Monero, most importantly is that ZkVM provides you with this customization and the smart contract capabilities that those don't. And it is way more scalable because both Zcash and Monero, they're also, their approach is to hide the transaction graph natively. And this creates a big bottleneck because now there is no clear notion of unspent coins, and you have to track all the coins effectively to prevent double spends. And this creates a huge problem for scalability. And finally, ZkVM is natively focused on issued assets, while Zcash and Monero just have a single coin within themselves. So that's a quick kind of run through the ZkVM. It provides practical confidentiality solution combined with stateless and scalable smart contract capabilities. The cryptography is very high performance, and it's pretty conservative compared to other kind of privacy-oriented blockchain designs. And it's focused on keeping the least amount of complexity at the kind of blockchain layer, pushing more complexity to the application kind of off-chain area. So that's everything I got to say about kind of the introduction. So now I'd like to invite Lindsay and David to share their thoughts and their questions so we could discuss the challenges.
So do you want to talk a little bit about how could two different instantiations of ZkVM interoperate through Stellar?
Great. Yeah. So imagine you have a system with a fully privately operated ledger, meaning that it's like a single entity that is placing the transactions on the book. And what they want to get out of this technology is to make their ledger auditable in real time, right? And it could be one organization doing that with their data and another one with theirs. So they would have completely independent instances. And first of all, they would need those confidentiality features to actually hide the sensitive information from randomize. But then when they want to interact with the mainnet, with the Stellar, what they have to do is to implement some kind of import and export mechanism where you would effectively transfer lumens or other Stellar assets to the designated address held by the kind of controlled by this institution, and they would issue a corresponding amount of the mapped asset on their private ledger, and vice versa. So when you kind of destroy or kind of move out the asset to a specific location on the private ledger, then they would unlock and transfer back the Stellar asset on the mainnet to you. So they kind of act as this kind of bank where you deposit the external assets and you get the internal representation. But it could be done in a fully auditable, transparent manner. So once you have the properly well-formed transaction on Stellar side, with like proper annotation, meaning like I want this lumen to be delivered to this like ZkVM address. So that's one transaction. And on ZkVM, you could say, I want to withdraw this lumen to that Stellar address. So there will be a clear specification of the withdrawal address. So this is how you could implement it. Unfortunately, to kind of enforce this on the mainnet, the mainnet would have like mainnet validators would have to know about all this private chains, which kind of defeats the scalability.
Well, why couldn't you do the why couldn't you do sort of the solvency checks offline? So I'm imagining, like, let's say, I'm an institution, I have a whole bunch of customers, and my customers, they might be trading with each other, but I want them to be able to kind of send asset payments to anybody else who's connected to the Stellar network, right? And then maybe somebody else is kind of in the same boat where they have aggregate customers. So maybe what I'm doing is I have a bunch of like anchored dollars, right? And so I have a Stellar account that has that many anchored dollars sitting in it. And then I have a ZkVM that is privately sort of distributing those dollars among my users. And so what I really want to be able to do if I want to convince people that I'm solvent is I want to prove to the world that the public sort of aggregate balance you see in my Stellar account is equal to kind of the sum of how much all my customers think they're holding on the ZkVM ledger.
Oh yeah, you can totally do that. So you could like you make your ZkVM ledger public, so people can see, okay, this is a correct commitment of your institution to that kind of state of the system. And then you can provide the proof that, like, presumably all your individual balances are encrypted. So they are, first of all, disconnected from specific names. And second of all, you don't want to disclose the distribution. So you could prepare a proof, which would be pretty efficient, that the sum total of all these individual balances of your clients amount to this, let's say, like million lumens on this specific address that you control on the mainnet. So you could provide the proof like that, and you can do this pretty much in real time. You can do this like like every minute, I think. Does this answer the question, or I misunderstood?
Yeah. And I'm kind of curious. So Lindsay, like, what do you think? Like, what would the regulatory burden be if I wanted to use ZkVM to kind of allow a bunch of customers to share a pool of assets that I have in an account on the Stellar network?
Well, I think overall, Oleg, I think ZkVM is an amazing invention of yours, and I honestly can't wait to see it actually implemented with Stellar or some other way. What we've been hearing from businesses that are using Stellar is that one of the key concerns that they have about Stellar is that transactions are, they are pseudonymous, but with enough research, you can really figure out who is behind each of the accounts. And that makes it really difficult for them to use public ledgers because they want to keep certain user information confidential. And also they want to keep vendor information, customer transactions, and also their transactions with other financial institutions confidential. And so I think ZkVM could be a good solution to that sort of need, the need for businesses to keep certain elements of their day-to-day business operations confidential. I think, stepping back in the privacy space, in the privacy topic in the crypto industry, I think you'll see that some people think that there is not enough privacy on public blockchains, and then some people think that there is too much privacy in blockchains. And businesses and users tend to think that there isn't enough privacy on blockchains because accounts are only pseudonymous and the transaction values can be audited and they can be like triangulated to figure out who has been transacting what where. And there are tools to do that, like chain analysis and elliptic. And then businesses, on the other hand, think there is too much privacy on public blockchains. And they are actually, there is a AML standards and monitoring organization called the Financial Action Task Force, FATF, that is actually proposing that its members, which includes the US, the EU, and many other countries, it's proposing that its members adopt laws that say that self-hosted wallets should be limited. For example, cryptocurrency platforms like Coinbase or Kraken can't interact with self-hosted wallets, or they need to introduce limits on self-hosted wallets or other limits. And this is so that they can have more information about what goes on in cryptocurrency exchanges, because self-hosted wallets for them, it still seems like a pseudonymous, like an anonymous user wonderland. And I think for ZkVM specifically, I think what we'll run into if ZkVM becomes super popular, or if any privacy solution becomes extremely popular and the use of crypto grows extremely large and just becomes a real phenomenon rather than a niche like hobbyist I guess activity, then we'll definitely see that governments will want to impose some sort of reporting or monitoring or restrictions on the ability of certain regulated institutions to be able to interact with things like ZkVM, or things like restrictions on like how much can be, or requirements what must be reported if you do use ZkVM as a regulated financial institution. So I foresee that ZkVM will be extremely important for helping businesses keep information private from the world. But though definitely, I think governments will want to see, have access to certain information contained in the ZkVM, and want to, make sure that cryptocurrency is not being used for tax evasion, monetary control violations, money laundering, or terrorist financing, which I think are very worthwhile functions and goals. But it definitely has to be balanced with, the friction that it imposes on the institution.
Well, one thing that strikes me about ZkVM, though, is that it's sort of well placed. I mean, there's a number of ways you could deploy these technologies. ZkVM seems reasonably well placed to kind of approximate what we have today. And that, for example, if you're using ZkVM to expose net flows between organizations, I mean, what you have today is, the government doesn't see every transaction that happens at my bank, right? But the bank's required to file suspicious activity reports, and and then they could be subpoenaed or whatever. And so it seems that what you have with ZkVM is you do know who is transacting with whom, but you don't know sort of how much they're spending. So if you see that. So if you kind of add a level of indirection where, like, I tell my bank that I want to purchase a plane ticket from United Airlines, say, right? Well, the fact that like Wells Fargo made some payment to United Airlines, that's not like super surprising, right? That doesn't really reveal that much. Whereas if I were personally to expose myself as doing that transaction, then everyone would know that I'm leaving town, or could, very likely conclude that. So, so it seems like ZkVM is maybe well positioned for kind of connecting institutions that themselves aggregate larger numbers of individual customers, and those institutions could potentially have regulatory responsibility and carry that out in such a way that this would be acceptable.
Yeah, I agree with that. it seems like ZkVM keeps certain information confidential to the parties that you don't want to reveal the information to, and then has the ability for institutions to disclose relevant information to those that need it, like the government.
Yeah, there is just kind of like to wrap up. I mentioned that ZkVM is more like a TLS to the internet of value, and this is also in contrast to Tor, for instance. The ZkVM's goal is not to kind of go to extra lengths to try to obfuscate the the graph of connections and graph of kind of value transfers. It's just focusing on the data, which is just a technical decision to make things scalable. And this is kind of maps to how the internet is used with TLS today. Also, your ledger is effectively providing you with this hooks and building blocks to do all sorts of like proofs and disclosures. So you could provide necessary, compliance data and compliance proofs. You can like prove in like zero knowledge the net asset value worth in dollars without even disclosing what assets you're holding, for instance, if that's all that is needed to be disclosed. So this on kind of one hand provides a lot of like ways to be compliant, but also in a way that protects the privacy where it doesn't need to be violated. When the regulatory agency needs to know some, some summaries, some statistics, you could provide just exactly that without hurting your business. So this is the kind of important distinction, which places us in, like David says, in the sweet spot. We're not trying to like hide everything and be like super underground, but at the same time we don't want to just spill data all over the place whenever anyone has any regulatory concern. We want to be very like specific. So that's the goal here. So yeah, I think it's time up, and thank you, David and Lindsay, for participating. So I hand over to Justin.
Thanks, Oleg, and thanks, David and Lindsay. It's definitely a fascinating topic, and there's a lot to think about, a lot left to explore. I feel like we're just scratching the surface. I'm definitely interested in seeing ZkVM continue to evolve. It's kind of like Goldilocks, right? Like the Goldilocks protocol, not too hot, not too cold, right?